Welcome to the chapter Operating Systems, Linux Advanced for Security, part of the course CyberSecurity and DevSecOps Expert. Develop, PenTest, and deploy secure applications. This chapter is designed for learners who are at a beginner level in Linux and cybersecurity, but who have a professional ambition to become cybersecurity and DevSecOps specialists. Whether you are transitioning from a development background, a system administration role, or an entirely different field, this chapter will give you the foundational and advanced Linux skills that are absolutely essential to operate effectively in the security domain. Before diving into the technical content, it is important to understand why Linux is central to cybersecurity and DevSecOps work. Linux is the dominant operating system in server environments, cloud infrastructure, and security tooling. The vast majority of web servers, databases, and containerized applications run on Linux. Security tools such as Nmap, Wireshark, and Metasploit are primarily designed for and used on Linux systems. Penetration testers, security engineers, and DevSecOps professionals spend a significant part of their working day inside a Linux terminal. Without a solid understanding of Linux, you cannot effectively perform security assessments, configure secure pipelines, or respond to incidents. What this chapter covers. This chapter goes beyond basic Linux usage. It is not about learning how to install software or navigate directories for the first time. It assumes you have had some exposure to Linux commands and builds upon that to cover topics that are directly relevant to security work. Here is what you will study. File system structure and permissions. Understanding how Linux organizes its file system is critical for security. You will learn what directories like /etc, /var, /proc, and /tmp contain and why they matter from a security perspective. For example, /etc /password and /etc shadow store user account information, and misconfigured permissions on these files can lead to privilege escalation. User and group management. Security heavily depends on the principle of least privilege. You will learn how to create, manage, and restrict users and groups. You will understand how the root user differs from standard users, and how the sudo mechanism allows controlled privilege escalation without sharing the root password. Process management and monitoring. You will learn how to list running processes, identify suspicious activity, and understand how processes interact with the system. For example, a process running as root that was not started by a legitimate administrator can be a sign of a compromise. Network configuration and analysis from the command line. You will learn how to inspect network interfaces, active connections, open ports, and routing tables using tools like IP, SS, and Netstat. Understanding what network activity is normal on a system is the first step to detecting what is abnormal. File permissions and special attributes. Beyond standard read, write, and execute permissions, Linux has special bits such as the setoid bit, the setchid bit, and the sticky bit. These are frequently exploited in privilege escalation attacks. For instance, a binary with a setoid bit set and owned by root will execute with root privileges regardless of who runs it. Finding these files on a system is a standard step in a penetration test. Log management and analysis. Linux systems generate extensive logs stored in /var/log. You will learn how to read and interpret system logs, authentication logs, and application logs. Logs are often the first place a security professional looks when investigating a potential breach. Bash scripting for security automation. Writing scripts in Bash allows you to automate repetitive security tasks such as scanning log files for failed login attempts, checking for recently modified files, or automating the execution of security checks. You will write practical scripts as part of this chapter. Hardening Linux systems. System hardening means reducing the attack surface of a system by disabling unnecessary services, enforcing strong password policies, configuring firewalls using tools like iptables or enftables, and applying security patches. You will learn concrete hardening techniques that are used in professional environments. Cron jobs and scheduled tasks. Attackers often use scheduled tasks to maintain persistence on a compromised system. You will learn how to configure, list, and audit cron jobs, and how to detect malicious scheduled tasks. Environment variables and their security implications. Environment variables can be manipulated to influence the behavior of programs. Understanding how they work and how they can be abused is important for both offensive security testing and defensive hardening. Why these topics matter for your professional goals. Your professional goal in this course is to become a cybersecurity and DevSecOps specialist. This means you need to be able to understand the risks of an application in its operating environment, conduct authorized security assessments of web applications and application programming interfaces, identify and validate vulnerabilities such as injection flaws, broken authentication, improper access control, and cross-site request forgery. Use tools like Nmap, Wireshark, Metasploit, and Python scripting. Produce professional vulnerability reports, and set up secure software delivery pipelines including static application security testing, dynamic application security testing, and software composition analysis. Every single one of these objectives requires Linux proficiency. When you run nmap to scan a network for open ports, you will be doing it from a Linux terminal. When you use Metasploit to test an exploitation path, you will be operating inside a Linux environment. When you configure a continuous integration and continuous delivery pipeline with integrated security testing, the pipeline runners almost always execute on Linux-based containers. When you write a Python script to automate a security check, that script will likely run on a Linux server. In short, Linux is not just one tool among many in this course. It is the operating environment in which most of the work happens. Mastering it at an advanced level is not optional. A concrete example to illustrate the stakes. Imagine you are conducting a penetration test on a web application. After exploiting a vulnerability in the application, you gain a shell on the underlying Linux server. At this point, your ability to navigate the system, understand what you are looking at, escalate your privileges, and move laterally depends entirely on your Linux knowledge. You check running processes with the pso command and notice a process running as root. You look at the /etc/cron tab file and find a script that runs every minute as root. You examine that script and see it calls a file in the /tmp directory that is writable by all users. You replace the content of that file with a command that adds your user to the sudoers list. 1 minute later, you have full root access to the system. This is a real class of attack called a cron job privilege escalation. It is only possible to detect or execute this attack if you understand Linux file permissions, the cron scheduling system, process ownership, and the sudo configuration file. This example illustrates exactly why advanced Linux knowledge is a prerequisite for effective security work, both offensive and defensive. How this chapter is structured. This chapter is structured progressively. Each lesson builds on the previous one. You will start with a review of the Linux file system and permissions, move into user and process management, then network analysis, then scripting and automation, and finally system hardening. Each lesson includes practical exercises that you should complete in a Linux environment. A virtual machine running a Linux distribution such as Ubuntu or Kali Linux is recommended. Kali Linux is particularly relevant because it comes pre-installed with many of the security tools you will use throughout this course. By the end of this chapter, you will be able to navigate and administer a Linux system with confidence, identify common misconfigurations that represent security risks, use the command line to perform basic security analysis, write simple bash scripts to automate security tasks, and apply standard hardening techniques to reduce the attack surface of a Linux server. These skills are immediately applicable. The skills you develop in this chapter are not theoretical exercises. They apply directly to the tasks you will perform as a professional. System administrators, security engineers, penetration testers, and DevSecOps practitioners use these exact commands and techniques daily. Employers in the cybersecurity field expect candidates to be comfortable in a Linux terminal. Certifications such as the Offensive Security Certified Professional Examination, the CompTIA Security Plus Examination, and the Certified Ethical Hacker Certification all include significant Linux content. Investing time now pays dividends throughout the course. It is strongly recommended that you do not rush through this chapter. Every subsequent section of this course, whether it covers web application penetration testing, vulnerability reporting, or DevSecOps pipeline configuration, will assume that you are comfortable with the Linux concepts covered here. If you find a topic challenging, take the time to practice it in a terminal before moving on. The effort you invest here will make every other chapter significantly easier to understand and apply. Welcome to the journey. Let us begin.